So very good morning to you, and you're very welcome to today's Signpost webinar, wherever you're joining us from today. We hope you're keeping safe and dry because we know it is a wet one out there today, particularly in Ireland. As we face increasing pressure to reduce input costs and environmental impact on Irish farms, optimizing grassland productivity with minimal nitrogen use is more critical than ever. And today we're going to be discussing the lowering the carbon and ammonia footprints of LoCAM dairy farms. And we're delighted to be joined by Emma Buckley, who's a PhD and Walsh Scholar, is a PhD student and Walsh Scholar in the Livestock Systems Research Department in Teagasc. And we're also joined by Dr. James Humphreys, who's a research officer in the same department, the Livestock Systems Research Department. And Cathal Somers is joining us from Johnstown Castle. Cathal is a water quality specialist, and Cathal, you're going to be helping us out with questions later on in the morning.
That's right, Mark. Yep. So don't just remind people to just put their questions into the Q&A all the way through, and we'll have plenty of debate and chat at the end.
Great. Thanks, Cathal. So, Emma, good morning to you. You're very welcome. Perhaps you could tell us, Emma, a little bit about the work that you're doing in Moore Park there in the Livestock Systems Research Centre.
Good morning, Mark. Thanks for having me on. So yes, today we're going to have a look at some of the farmers that are part of the Low Carbon Dairy Farms project. We're going to have a look at their nitrogen use on their farms, how they maintain their herbage production, and in turn we're going to have a look at their carbon footprints then.
Right. And this is really timely. We know that Irish farmers, or agriculture in Ireland has a target reduction of 25% reduction in gaseous emissions or greenhouse gases before 2030. So this is highly relevant research. There have been inroads made by farmers, I know, in the last number of years in terms of reduction of nitrogen and the type of nitrogen being used. So this is getting closer to really driving down the use of nitrogen.
Yeah, exactly. And I think this group of particular farmers are working hard towards this. And we'll have a look now at some of their footprints and their reductions so far.
Brilliant. Okay, super. And James, I know you're going to help us out with questions later on as well. So we will pull you in at that stage. So
Thanks,
Emma,
Mark.
if you could share your screen with us, and while you're doing that, to remind everybody that today's session is being recorded and will be available on the Teagasc YouTube channel in the coming days, along with Emma's presentation. And also we will have this available as a podcast version if you wish to listen in on the move. So Emma, we'll hand over to you, and we'll take some questions afterwards then.
Perfect, thanks very much. So yeah, we're going to have a look at lowering the carbon footprints of the low carbon dairy farms. So who are the low carbon dairy farmers? They're a group of commercial dairy farmers spread across a wide geographical distribution, which we can see here in the map on the right hand side. And they are coming from many different soil types. And this was something that was very important to us when we started this study. The key focus of this group of farmers is to cut costs on their fertilizer and nitrogen use while maintaining their herbage production and milk production. So the farmers have been achieving this. They began by gradually converting to clover-based swards. And we as researchers are very interested in seeing how this is going to impact on their farm's carbon footprint. So where do these greenhouse gas emissions come from on these intensive dairy farms? Well, 50% of the greenhouse gas emissions are coming from methane due to enteric fermentation from the dairy herd and their replacements. An additional 20% of these greenhouse gases are emitted in the form of methane and nitrous oxide from slurry storage and slurry application. Another 20% of the greenhouse gases are produced in the form of nitrous oxide, and they are emitted as a result of fertilizer applications. And then the final 10% of the greenhouse gas emissions are composed of carbon dioxide. And this is as a result of emissions released from fuel by farmers or contractors, or likes of electricity used on the farm for the parlour and so on, and fertilizer manufacturing. So the data that I just showed you there was taken from the work that was conducted by Marion Sorley, which was recently published. we can see here in the graph that 19% of the greenhouse gas emissions are coming from fertiliser nitrogen use on these intensive Irish dairy farms. So this is an area that we are targeting in order to lower our emissions. This work was published in the Journal of Cleaner Productions recently. So we can see the impact that cutting the fertiliser and nitrogen use can have on national emissions. And these are some of the reductions of emissions between 2022 and 2023. So there was a 4.6% reduction in agricultural emissions in Ireland. And this reduction coincides with an 18% decrease in fertiliser nitrogen due to the spiking fertiliser prices as a result of the war in Ukraine. This decrease happened despite the reduction, despite an increase in dairy cow numbers. And also there was a slight reduction in milk price due to poor conditions during the year. So this reduction in emissions just shows exactly what can be achieved on a national farm level. So now we're going to take a look at what impact does the reduction of fertiliser nitrogen use have on herbage production. So I'm going to present a long-term data set here, which shows grass clover herbage production across a number of different sites. So firstly, we're going to take a look at work that was most recently completed at Solihead. So you can see up above here that we have 3 different treatments that were imposed on this study. A high nitrogen system of swards receiving over 250 kilos of nitrogen. We have a spring nitrogen system with grass clover swards receiving approximately 60 kilos of nitrogen. And we have a zero nitrogen system on grass clover swards that received no chemical nitrogen. So the Cashman et al. Study shows 4 years of published data, and the 5th year, which is 2023, is data that I hope to publish soon. We can see the key message from this particular set of data is there's no difference between the 3 systems, their herbage production, and on average, they grew 14.9 tonnes across 5 years. We can see here now an additional 2 years of high nitrogen and spring nitrogen systems, also published by Cashman et al., with no zero nitrogen treatments involved. And this also shows no difference in herbage production, but there is some year-to-year variation. So this work, it tallies very well with earlier work that also took place in Solihead. We have a 2-year study by Tui et al., which shows a high nitrogen system versus a spring nitrogen system. And similarly, this study showed no difference in herbage production within the systems. There was year-to-year variation, as we can see, this we can see for 2012. This was due to high rates of rainfall. The next study we're going to look at is another study completed in Solihead, which includes 5 years of large plot-scale plot-based data under grazing by Valbuena et al. And this was also on clover-based swards, receiving no chemical nitrogen, showing that the swards did maintain good herbage production. Next is a 3-year plot-based study that took place under grazing at Moore Park, using similar treatments in the previous studies. And this trial took place from 2011 to 2013. So once again, there is no significant difference in the herbage production throughout the 3 different treatments. There was some year-to-year variation. We can see here in 2013 that there was a slight drop in production on all systems, and this was due to Moore Park suffering from a soil moisture deficit. And then the final study is a study that was conducted in Grange, and it's a 6-year study on red clover cider swards that received high rates of nitrogen and swards receiving zero chemical nitrogen. And we see again that there is no significant difference between these treatments. So the overall message to take from this slide is that there's no difference in herbage production between the systems in the long-term studies. We can see that the zero-N system has given high levels of production over many years across 3 different sites. And on this basis, it gave us the confidence to go out and recommend this to farmers within the group, especially when there's increasingly restricted fertilizer nitrogen use under the Nitrates Directive. So this work is all published in high-ranking journals. Another key reason for this research was to examine the impact of carbon footprint on farms. Further work that was carried out by Cashman et al. Shows reducing the rates of fertilizer nitrogen used will in turn reduce our carbon footprint on farm. So we can see here that the reduction in fertilizer nitrogen on a high nitrogen system to a low nitrogen system accounts for a 29% reduction in the overall carbon footprint. And this work was published in the Journal of Agricultural Systems recently. So we took a look at how reducing our fertilizer nitrogen use impacts on herbage production and carbon footprint, but I suppose the main question is, how does this impact on our farm profitability? So this graph shows that the net margins in the 3 different systems on the Cashman study. We can clearly see that the zero nitrogen system held its profitability with a 14% higher net margin than the high nitrogen system. And this was as we could maintain the same level of output with lower income costs. And this work is also published in the Journal of Agricultural Systems. So as there was huge interest in this research, many groups and farmers came to visit Solihull Research Farm. And many of the farmers after their visit became interested in adopting clover and began road testing it on their own farms. So this was when the low carbon dairy farms were formed by William Burchell and James Humphreys in late 2020. Initially, the group was predominantly based in the southern parts of the country, and then another group joined, led by John McCabe, in the western part of the country, and they joined in early 2022. So now within the group, we have 24 intensive dairy farms across a wide range of the country, from Donegal to Cork and across the Midlands on numerous different soil types. So some of the objectives of the low carbon dairy farms: farmers want to cut their costs by reducing their fertilizer nitrogen use. And they are going to do this by gradually converting their farms to clover-based grassland. They began reseeding, so it was recommended to reseed 10% of the farm with clover mixture each year. And then they could go step-by-step reduction in a fertilizer nitrogen use over time. While doing this, they also aim to maintain both their herbage and milk production. And by reducing their fertilizer nitrogen use, we'll look at how this impacts on their carbon and ammonia footprints, and also an evaluation of the farm's economics performance will be looked at. And today we're going to focus on the reduction of fertilizer nitrogen use within the group. We'll also take a look at their herbage production data over a number of years and the carbon footprints of the group. So what do some of these low carbon dairy farms look like? So we have some farm characteristics here, average over the years, over a 3-year period from 2021 to 2023. And we can see here that the average total agricultural area of these farms is 90 hectares, and this ranged from 43 to 188. Average stocking density was 2.37 livestock units. This varied from 1.63 to 2.73. The average number of dairy cows was 167, and this ranged from 61 to 332. The average fertilizer nitrogen use across the 3 years was 159 kilos per hectare, and this spanned from 102 to 204 kilos. The average concentrate fed per cow was 841 kilos, and this varied from 527 to 1,370. The average milk sales was 948,000 litres, and this ranged from 292,000 to 1.8 million litres. The average milk solids per cow was 493 kilos, and this varied from 426 to 577. Average milk solids per hectare was 922, and this ranged from 563 to 1,369. The average co-op price for the 3 years was 51 cents, and this varied from 46 cents to 59 cents, and the average net margin, including direct payments, was €2,491 per hectare, and this varied from 1,423 to 4,265. So in order, so farmers, there 24 farmers in the group to give us, provided us with very detailed data. And firstly, each member of the group would complete an Acorn agricultural survey, and they would complete this on a monthly basis. And this survey provided us with data such as fertilizer, lime, and ration purchases. It also included any machinery work that was completed by the farmer or contractor, any fodder movements that were recorded, any dairy detergents or sprays used, and it also included turnout and housing dates. Farmers then would also record both their herbage and fertilizer data onto Pasturebase, which we had access to. Each farmer completed a profit monitor, and we also had access to their nutrient management plans and ICBF for milk production and stock movements. We'll take a look now at the group grassland production for 2021, 22, 23 and 24. So with 2021 being our baseline year, the farmers assigned their paddocks to each of the following management practices. So the farmers chose which management practice they used on a per paddock basis, and this was determined by their clover contents on their swords. So the first management practice was a zero nitrogen practice, where grass clover swords received zero chemical nitrogen. The second management practice was the spring nitrogen practice, with grass clover swords that received less than 100 kilos of nitrogen. Then we had a spring nitrogen and half rate practice, where the grass clover swords received over 100 kilos of nitrogen. And the final practice was the high nitrogen practice, where grass only swords received high rates of chemical nitrogen. So this is the pasture production and fertilizer nitrogen use relative to the baseline year of 2021. We can see across the 3 years of 2021, 22 and 23 that the group grew approximately 13.5 tonnes of dry matter each year. So it's important to note here that there was no difference in pasture dry matter production for 21 to 23 for the group, all while they were steadily reducing their fertilizer nitrogen use. So we can see that there was a 32% reduction in the fertilizer nitrogen use in 2023 relative to the baseline year of 2021. So this is a huge reduction. There was a half a tonne reduction of pasture dry matter and an increase in fertilizer nitrogen use in 2024. And this was mainly due to the poor growing conditions in the spring of 2024 that farmers don't really need much reminding of. All in all, though, there was still a 21% reduction in their fertilizer nitrogen use from 2021. And this is something as a group that we're going to work on this year. So now we'll take a look at fertilizer, nitrogen and pasture production for 22, 23, 24 by the 4 different management practices. So firstly, we have the zero management practice here in the green. And the first bar here you can see is 2022. The second bar is 2023, and the third bar is 2024. And this is the same for the spring nitrogen system here in red, the spring nitrogen and half rate in purple, and the high nitrogen system in blue. We can see the average, the annual average fertilizer applied to each management practice on the x-axis here at the bottom. So we saw no difference in pasture dry matter production between the different management practices. This is all despite the very large differences in the fertilizer nitrogen use. So looking at their fertilizer nitrogen use and the carbon footprint per hectare, we have 11 farms of data here for 2022 and 2023. And this is because these are some of the earlier adopters that provided me with data earlier on. I am currently still working on the 2024 data, and I hope to have that soon. So we've seen for 2022 in the green, we can see that the average fertilizer nitrogen use was 155 kilos per hectare, and this resulted in a carbon footprint of 14.7 tonnes of carbon dioxide equivalent per hectare. In 2023, we can see there was a reduction in fertilizer nitrogen use to 109 kilos per hectare, and this resulted in a carbon footprint of 12.6 tonnes of carbon dioxide equivalent per hectare. So there was a 30% reduction in fertilizer nitrogen use from 22 to 23, which gave us a 14% reduction in our overall carbon footprint. So now we're just going to have a look at some of the members of the group, and we're going to provide you with some of the case studies. So first up, we have Tom Carr, and Tom is farming at Parkdove Farm in Whitechurch in County Cork. Tom has approximately 25% of his farm under a clover-based system, and his average fertilizer use, his average total agricultural area was 86 kilo. His average total agricultural area was 86 hectares across the 3 years. His stocking density increased slightly from 2021 to 2023. His milk sales remained similar with a slight drop in production in 2023, and this was mirrored in his milk solids. He fed approximately the same amount of concentrate throughout the 3 years. I suppose the key point to note here is Tom's fertilizer nitrogen use and his reductions that he's made. So in 2021, Tom applied approximately 230 kilos of nitrogen per hectare. This was reduced further to 219 in 2022, and further again to 163 kilos in 2023. So this reduction in fertilizer nitrogen use resulted in his carbon footprint being 16.9 tonnes in 2022 to a reduction and it was reduced significantly to 14.5 tonnes in 2023. So Tom is a good example of a farmer that cut his carbon footprint by reducing his fertilizer nitrogen use. So some other members of the group include Pat and Ray McLaughlin, and they're farming in Rath in County Offaly. And the McLaughlins have approximately 80% of their farm under a clover-based system. On average, their total agricultural area for the 3 years was 43 hectares. Their stocking density decreased slightly from 2021 to 2023, and their milk sales remained similar with a slight increase in production in 2023. And their milk solids mirrored this. Their average concentrate fed remained similar across the board. And we can also see here that their fertilizer nitrogen reduced from 2021 to 2023. So in 2021, they spread approximately 161 kilos of nitrogen. This was reduced to 86 kilos in 2022, and a further reduction to 60 kilos in 2023. And the McLaughlins are an example of a very low carbon footprint in comparison to the group average of 14.7 in 2022. So their carbon footprint was 7.9 tonnes in 2022 to 88.1 tonnes in 2023. And the final case study that I'm going to present to you is John and Brendan Walsh, who are farming in Ballyluby in County Tipperary. John and Brendan won the FBD Teagasc Environmental Sustainability Award in 2024. Their average agricultural area was 102 hectares across the 3 years. Their stocking density increased slightly from 2021 to 2023, and their milk sales remained similar across the board, which was mirrored similarly to their milk solids. Average concentrates fed were similar enough, and their fertilizer nitrogen use, we can see it's a common trend, reduced from 181 in 2021 to 132 in 2022, and finally to 115 in 2023. So their fertilizer nitrogen reduction, they had a reduction of 36% relative to the baseline year of 2021. So this coincides with their carbon footprint, their fertilizer nitrogen reduction from 2022 of 11.6 tonnes to which was reduced to 10.3 tonnes in 2023. So when farmers began to adopt clover, we gave them some recommendations in their conversion period. So they were to reseed a manageable area of the farm, so approximately 10% per year. They were to ideally reseed in April if possible. When sown, they would apply 2 bags of 10, 10, 20, and then they were recommended to not apply any more fertilizer nitrogen for the remainder of the year, and to solely rely off of the biological nitrogen fixation of the clover plant. So we can see here a 6-week-old white and red clover seedlings. You can see the nodules here present on the plant, and these nodules have the ability to fix up to 225 kilos of nitrogen in the establishment year. Applying a post-emergent herbicide for dock control was recommended also, and also to ensure that there was good soil fertility and lime when needed. So these are just some examples of the seed mixtures that were recommended to the group. It was recommended to include 2 kilos of red clover and 2 kilos of white clover to the grazing mix. And some of the silage recommendations included 4 kilos of red clover and 2 kilos of white clover. And this box on the right-hand side just shows some of the recommended red clover varieties that were given to the group. And just some final comments then to conclude. So there's huge expenditure on fertilizer nitrogen by Irish farmers each year. And for example, in 2022, there was €1 billion spent by Irish farmers on fertilizer nitrogen. The incorporation of clover to replace this fertilizer nitrogen to cut costs will also act and help us protect against future shocks in fertilizer prices, similar to in 2022 when the price spiked to the war in Ukraine. By reducing our fertilizer nitrogen use, it'll also, we found in this group, substantially lowered the greenhouse gas emissions within the study. They also found no reduction in herbage and milk production. And these intensive dairy farmers show, this group of intensive dairy farmers show exactly what can be achieved at a national farm level. And we believe that by reducing our nitrogen fertilizer use, we have the potential to lower our national greenhouse gas emissions from agriculture. And finally, we'd like to thank all the farmers involved in the LoCAM or the low carbon dairy farms. We appreciate all the data they've provided over the last number of years. We'd also like to thank the Department of Agriculture, especially the 00 project, the Circ Agric project, who parts funds my PhD, and also the low carbon dairy project. So thank you very much.
Great, Emma. Thank you so much for sharing those results. Some really interesting results coming out there. Just you know, an overall question for you. I did note that last year the figures for nitrogen usage had increased again. I think it was somewhere in the region of 10%. Is that reflected in on the farms? That we have data on that yet?
Yeah, well, I suppose 2024 was quite a difficult year. The spring especially was quite tough on all farmers across the country, and I suppose it was only natural to go out and put out that little bit of extra fertilizer, to give farmers confidence that they'll have the grass there to feed their cows.
Yeah, well, I also note that it is still within we're still on target for the reductions that are
Yeah,
needed
it
for
was
20.
still a 21% reduction. It was still quite a big reduction from the 2021, the baseline year. So it's
Yes.
something that we'll work on this year and see where we go.
You presented Pat and Mairead McLaughlin's farm, and they seem to have a very low carbon footprint compared to the other operations. How was that explained, or what was the reason for that?
Well, Pat and Mairead actually have 80% of their farm on the zero nitrogen system, or management practice. So I suppose like on average in 2023, they spread 60 kilos of chemical fertilizer. That's a huge reduction on farm, and it's a
Right.
testament to them.
But yet they were still maintaining very
Still maintaining the
acceptable levels of
production.
production at the
Yeah,
same time.
yeah.
No, that's excellent. Yeah, I presume these farmers are hosting other farmers. Is that part of the program, that there would be some demonstration aspect to this?
Yeah, so within the group, we probably meet 3 to 4 times a year. We organise farm visits between the group, and I think it's a great way for them to learn off of each other. It gives them great confidence to strive on and work towards lowering their fertilizer nitrogen use. And I suppose if they see it being achieved on other farmers within the group, they maybe believe they could give it a go at home.
Mhm. Excellent. And James, I know that that a lot of people would say the technologies are there, but yet, adoption is still lagging in some cases, particularly around, the lower nitrogen systems. What would you attribute that to? Is there more support needed, or what is the?
It's like anything. It's relatively new. Like we've been using fertilizer now for a long time in this country. We've things worked out very well in terms of our grassland management. Very sophisticated management uh, guidelines, and farmers know how to do it. This is a change. It's new, and with anything new, there's a certain amount of fear, and,
Hmm.
and I think we saw that in 24 when we had very bad conditions in the spring, very wet conditions. Grass wasn't growing. And I think it's only natural then that farmers went on with more nitrogen last year, but I think we can go forward again this year. Like we're seeing a gradual transition to clover on these farms. And I think it's all a matter of building confidence. And as Emma said, our recommendation at the beginning is just to reseed 10% of the farm, put in a good seed mixture, and stop with nitrogen fertilizer and see how you get on and start building your confidence. And then, like, I think one of the big advantages of this group is that we're collecting a lot of data and we're feeding that data back to the farmers. So even like last year, for example, some people feel that the clover isn't performing as well as they'd like, but then when they see the overall data, nothing performed as well as they like last year, even the high nitrogen paddocks. And when you have a direct comparison within individual farms, that's very strong data to be able to feed back. And I think that's the foundation that we can build on. And then the question you were asking about wider dissemination, like all of these farmers are hosting visits by discussion groups. And, like Dennis O'Donovan was on ear to the ground there last night. Like he's hosting a huge number of groups down locally in West Cork. We have other farmers in other parts of the country. To mention Ger Pardy, like he hosted a huge number of groups before he passed away, which was a huge loss to his family and friends and everybody else, but also a huge loss to the project. He was a real innovator and really took it on, and as I said, hosted a huge number of groups. And we're seeing that, and that's part of why we went for this wide geographical distribution as well. And of course, we have WhatsApp, and a lot of exchange is taking place across WhatsApp. So a lot of exchanging of ideas. Sometimes I might put some things out there, and might be some bit of a negative response to that. But we live and learn, and we move forward.
Great, great.
But very
Just
positive.
Absolutely. A question, Emma, there in relation to the other metrics. Are you looking at the impact on water quality with these reduced nitrogen systems?
It's not something that I'm working on myself, but probably something that could be looked on with more students to come.
Great. Okay. Perfect. Cathal, we've got some really excellent questions coming through from our viewers this morning.
Yeah, some super questions, and just keep reminding people to put them in. Emma, I suppose just starting off with a slightly technical question. If you're changing from a system where you're using a good amount of chemical nitrogen and you're converting to try and get into clover and reducing your nitrogen, is there, I know some of the experiments that you presented in the earlier ones identified the response is a bit slower at the start. Does it take a bit of time for that kind of conversion to happen for the clover to settle in and get organized, or how does that work?
Well, I suppose if you're beginning the conversion, that you could go and try it on well, you don't have to go to 10%, but try it on a paddock or two. Leave that paddock, put the 2 bags of 10, 10, 20 after sowing. Leave it nearly as a trial. You can see for yourself, and just don't go with any more fertilizer on that paddock. See how it goes, and you could spread the fertilizer elsewhere on another paddock if you're lacking that bit of confidence, and you'll see that it will maintain its production similar to the high nitrogen system. I suppose it'll take a number of years to build up the reduction in fertilizer nitrogen by the time you reseed each year. And it probably is a bit of a slower process, but definitely worthwhile.
And when you incorporate the clover, then if there's residual pools of available nitrogen, the clover will kick off. But is it the fact that, as probably a kind of a comment here, that if you start putting nitrogen on top of clover, it'll get a bit lazy and it won't produce?
Exactly, yeah. You have to allow that biological nitrogen fixation to take place and give it its chance. I showed there that the clover plants can in the establishment year can achieve up to 225 kilos of nitrogen within that establishment year. So it's all about time and giving it its chance to take off.
Yeah, and did you look at, say, there's a comment here about the clover 150 farm trial? Did you look at that?
Well, these group of farmers are a separate group, but yeah, it's similar work being conducted. But yeah, we're trying to continue just to lower that fertilizer nitrogen use as low as we can possibly go.
Yeah, and there's a kind of a comment or a question here. Sometimes when we talk about zero N, you mean zero chemical N. What other forms of nitrogen can you use on those farms?
Well, I suppose it's very important to go out with the slurry. Slurry plays a huge important role on these zero chemical nitrogen systems. So good quality slurry with regular applications.
I think that's often confused, isn't it? When people say zero N, they forget about slurry altogether, and slurry is a really good nutrient.
But just to make the point, that slurry recycled now within the farm. So ideally,
perfect.
A lot of that slurry is produced December, January, put it out in the spring for spring growth. But it's really slurry recycled within the system. It's not that we're bringing in slurry from outside or something like that.
Yeah. And what are the factors, and I know you touched on this a bit about the McLaughlin farm that has such a really good carbon footprint?
Well, I suppose mainly it has to be their fertilizer nitrogen use. They've got the lowest fertilizer nitrogen use within the group. It's quite extraordinary, in fairness. They've worked very hard to establish that level of clover on their farm. 80% of zero nitrogen, zero N system on their farm is very impressive, and it's something that they still strive to keep working at and keep maintaining that level of zero nitrogen on their farm.
Yeah, and there's a kind of comment here to back it up that was kind of saying that you have a lower carbon footprint, less chemical nitrogen, same growth rates and lower costs, so you can't really go wrong with that. Back to the weather again. I know slashing rain outside now at the moment, but did the bad weather in winter spring 2023 have a negative effect on clover and mixed swards compared to ryegrass? I suppose you're looking at both sides of the coin.
I suppose if you look at the herbage production there that I presented, we've seen a drop in production more so in 2024. The production maintained itself in 2023. It was similar from 21 to 23. They grew 13.5 tons on average for those 3 years. We dropped half a ton in production in 2024, and this was mainly due to that very poor spring that we had in 2024. And we met in June in 2024, and the farmers were just discussing like how tough of a year that was, but they backed it up at the back end of the year, and they just seemed to bring up their tonnage during that period.
Probably a lot of that is around management and the soil type. To heavier soils, just be careful poaching, I presume, is it?
I think it's a really big concern. Like, does clover perform as well as chemical fertilizer under adverse conditions? And I think part of the reason, like Emma showed the long-term data sets there from Solihull, Moore Park and Grange, and you can see if you've bad growing conditions, nothing will perform, and you can see a big reduction in across the board high nitrogen clover-based systems. And I suppose it's a remarkable thing that they perform so similarly under very different conditions. I think the very interesting part of this study as well is that we can look at, we've farms from Cork to Donegal. I think we've got good data, good harvest production data on those farms. So, it allows us to test that question, that specific question: will clover perform as well as nitrogen fertilizer under a wide range of different circumstances? And
Yeah,
so far, it looks very positive.
That's an important point, James. Like, how did the farmers feel about adopting their management slightly just to account for, say, poaching and that, just to mind the clover for the year coming in?
Well, poaching isn't that much of a challenge. I think it's the low winter covers is a challenge for people, and the stopping fertilizer nitrogen, because it's almost like an addiction. And then when things start to go anyway wrong, any bit of drought kicks in, any bad conditions, the first instinct is to put on the fertilizer spreader and go out and to do something. And as the wise man said, sometimes the best thing to do is do nothing, but that's a hard lesson to learn.
Funny you should say that. Now, there is a question exactly around that. Now, you've kind of half addressed it. So if you have a clover sward and it's not looking so good, maybe the percentage is down a bit, and the grass is not coming the way you would like to, is it what you do in that? Do you put out a little bit of nitrogen, or do you just stick to your guns and trust the system?
I suppose in my book, you have two choices. You either stick to your guns or pull the plug and go high nitrogen again. And I guess that's the difference in philosophy. Like, we don't believe in cutting back nitrogen across the board. You either go very low or zero and high nitrogen on the other part of the farm, but there's no halfway house. That would be my way of thinking about it. The more nitrogen you put on, the more you're going to hit fixation. So the less you use, the better. So you're far better off, say Tom Carr there, for example, 25% of the farm under clover with low nitrogen, 75% of the farm with high nitrogen, and to gradually, stepwise, move across over time. Slow and steady transition.
Yeah. Slow and steady wins the race, as they say.
Very well.
Can I just ask Emma and James, just in terms of the supports that were available to those farmers during that transition, and I know some were maybe already closer to the low end system already, but was there advisory support provided to those farmers? And I'm just thinking of people viewing here today and say, well, it's okay for them. They had lots of support around them to make this change. What sort of support is needed to help farmers to make that transition? So it's kind of two-pronged question.
I suppose we have the WhatsApp with the group, which is very influential. Everyone can put their questions in if they're having any issues or anything at all. I think farmers learn most of other farmers, and they all grew in confidence as the study began by learning off each other and learning from each other's mistakes, and that was very important to each and every one of them. James might have something else to add.
So there's a lot of support. There's myself and William Burchell and John McCabe, and the WhatsApp is a great tool. But like as Emma said, the farmers themselves really are the ones that drive this. And I suppose we were having a meeting there lately, and one of the farmers said, like, a farmer will believe another farmer 100 times before they believe anything that we do in Salahead or anywhere else. You know, that's the real clincher, like, you know. Having it working out on farms, and like, as I said, if say Dennis O'Donovan or many of the other farms are hosting many groups across the country, like that's the thing that will bring about the transition.
Absolutely, yeah. No, it's really true. You have to, I suppose, tune into the people that are in a similar position to yourselves. We just have a question there. You mentioned in your presentation about post-emergence spraying for dock control, and we know that there are mixed experiences there with the clover safe type of sprays. Is how at the reseed, the question here is, at the reseed, is a case of spraying Roundup beforehand and a clover safe spray afterwards? Is it the case of spot spraying if required? Or maybe you could just maybe talk us through that practice that the farmers have used to control docks and that post-emergent issue.
I suppose I'll answer that one. Roundup works very well, and it's very important. Like the big risk with clover swards, or one of the risks, there are a couple of risk things we have to be aware of. One is dock control, and like if you don't control docks around the time of reseeding, you won't see the problem immediately, but 3 or 4 years down the line, you could have an enormous problem. And there is an opportunity to control docks around reseeding, and you can kill the old rootstocks with glyphosate. That has worked very well. And then the post-emergence herbicide is very important. And to date, we've been using Clovermax. There's questions about the availability of that. There's a newer product in Pro Clova, which doesn't work as well from our point of view, in that it kills red clover seedlings. So there's some management to have to be worked out around that. And we are looking at non-herbicide control techniques, because there is a question mark about the future of glyphosate and some of these other herbicides. So we have a PhD student who started recently on this question. It's in the 0-0 project. So it's 0 fertilizer, 0 herbicides. That's the ambition. I can aim high anyway. It might not succeed, but what we'd hope to do is to have some sort of an integrated control methodology around reseeding, how to get rid of the old rootstocks, and how to avoid seedlings coming in. And there's things we can look at.
And just out of interest, what sort of practices are being investigated?
I think one thing, and again, we want to test the things before we talked about them, but using a cover crop around reseeding seems to work well on organic farms. Putting in something like oats to get rapid round cover. They're the kind of things we look at. But it's work in progress. So I might be eating my words next year or the year after. So I won't say anything too soon. But it's work in progress.
Emma, I know you're focused on the technical side of it, but there's a comment or a question here about, and James, you touched on it. What a lot of technology we're asking farmers to adopt are behavioural changes. Is there anything down the line, maybe for behavioural science aspect of this project, maybe to help encourage people to adopt these new technologies or new practices?
Yeah, definitely. I think it's something that can be looked at in the future. It is a big behavioural change. You're going from, your old usual practices of going out with your fertilizer spreader to having to maybe draw back, and it can be hard and can be difficult to do. But I suppose when you start off small and see that it does work, and you can see within the group see as well, within the group that it works, it makes it that bit easier to, try it out. But yeah, it's definitely something that can be looked at.
And there's a kind of a question here around over the life of the project of what you're looking at the moment. How did the percentage clovers did they maintain well in the swards? And I know you're talking about a 10% reseeding kind of per year on farm. And I suppose if you look at the whole farm, 10 years, 10%, you're reseeding kind of one area every year. So what way does that work? Like, does the percentage decline then over time and it kind of balances itself out as you keep reseeding, or do you think 10% is enough reseeding? I suppose is the question too.
Yeah, I think it's enough for each year. I think you need to continue doing it. I suppose persistency will start to decrease as years go on, but it can be maintained by easing off, reducing on the fertilizer nitrogen use. I suppose that plays a big role in the clover contents within a sward. James might have something else to add.
Yeah, that's like in Solihead, clover persisted very well, and I guess what we learned was the things you have to do to make that happen. And zero nitrogen, I know it's a daunting idea for a lot of people, but you know, with the zero nitrogen system we had, we were pushing up on 30% clover. We were growing around 5 tons. So if we were growing close to 15 tons, and we showed the data, if 1/3 of that was clover, we were growing around 5 tons of clover, well, 4.5, 5 tons of clover. And for every ton of clover we were growing, we were fixing around 50 kilos of nitrogen. And that's the real target. So if we could 4 tons, 200 kilos of nitrogen, 5 tons, 250 kilos of nitrogen fixed. So you often get the question about, will the soil in Solihead run out of nitrogen, and these type of questions. The clover system we have is still a relatively high nitrogen system, and we wouldn't be getting the production that we're getting if it wasn't. It's just that nitrogen, the way it's generated, doesn't generate emissions, and that's the key to the whole thing. And if we put on nitrogen on that, then say, even if we put on some nitrogen in the spring, that will have a negative impact on our clover content, has a negative impact on our clover yield, and has a negative impact on later fixation. So it's getting that balance right. And then when you're in a tricky situation like last spring, grass isn't growing, what do you do? Do you put on nitrogen, or do you stick to your guns? And that's a tough question. That's a tough situation to be in. And I guess only time will tell, say for the group, how we kind of work through it and learn from it and take it forward. But
we have,
the expectation is clover will die out over time, and that's why we come in with the reseed. Sorry, Mark.
There's constant management required. We have a colleague, Seamus Carney, who's working on the Signpost program. I suspect Seamus is screaming at his screen this morning with his few comments here. Just he makes a very good point about one of the reasons that chemical nitrogen increased in 24 was that many farmers had pre-purchased chemical N in 2023 due to fears of fertilizer availability in the spring of 2023. So the 3-year average is 311,000 tons of chemical N, which is down from 408,000 tons of chemical N in 2018. So there has been a reduction of 24%. Almost and very close to the 26% reduction in 2030 target. So I think all farmers are to be congratulated on that really excellent work that's going on there. Seamus is also highlighting the lime element of the whole nutrient management story, and that lime, P and K need to be right first. On average, we need to be spreading a load of lime per 60 livestock units. Now, I suppose that's a general advice and needs to be based on soil sampling. But I guess liming, Emma, would have been an important part of the production system on those farms that you're working with.
Yeah, so all of those farms would be soil testing regularly, and they would be analysing those results and making their calls then to ensure that they do have the correct pH and the P's and K's are suitable for those reseeds.
You mentioned nitrogen fixation a bit there. How do you calculate it? How do you know how much that plant is pulling down?
I'll leave that one to James.
Okay, so it's like basically we model for calculating it, but it's based on a difference. method. And again, that's recently published, but it's like we measure sward quality, so we group protein content, so we get the total nitrogen uptake in the herbage. So if we grow 15 tons to make the figures around 3% nitrogen in that herbage, that's an uptake of 450 kilos of nitrogen per hectare. Background release in the soil is around 150 kilos on average. It'll vary a bit from soil to soil, but that's a difference of 300 then coming from somewhere, 50 kilos coming from the slurry, roughly speaking, and then 250 kilos from fixation, the slurry recycling within the system. So that's a rough calculation. It's a bit more detailed than that, but that's it in a nutshell. I hope that makes sense.
No, it makes perfect sense, and you kind of half answered another question again. So if you're putting more clover in your swards, and you mentioned that you analyze the herbage, so there's an increase of crude protein, I guess, and if that's the case, is there potential there to reduce maybe concentrates if you have better quality herbage coming in?
Well, the herbage quality comes out more or less the same. It's not massively, hugely different. And I guess the way we feed concentrates generally is more to fill feed deficits rather than supplement the cows, if you know what I mean. So like when we see the change in concentrate feeding there from year to year, you can't say it's really, it's more strategic use of feed rather than supplementation. If you know what I mean, Cathal, but
yeah.
Yeah,
no, that's
if you get drought conditions, you'll go in with a couple of kilos concentrate. If you get very wet conditions, you can't get cows out to grass, you're going to feed a bit of concentrate. And that is more bearing on how we feed concentrate than.
Particularly if just keep milk flowing a bit. Yeah, no, that's fair enough. And there's several questions around soil type. Which is your favorite soil type, Emma, to plant clover, or does it matter, or maybe management practices are more difficult than some soil types?
Well, I suppose we just see there on the map, like we have loads of different soil types from across the country. So I think it's more once that your soil indexes are correct, your pH is correct, I think it'll grow. So I think that's a key point of this group, is that there's a large geographical spread across the country, and it's growing in all those different points.
It probably just makes it a
little
little bit more.
Today, anybody would settle for a dry, free draining soil. So
yes.
Whether it's fertilizer or clover.
I'm afraid we're coming towards the end of our session this morning. I don't know where that hour went. Emma, thank you so much for joining us this morning and sharing your results, and James also for coming in and supporting the questions. I just want to say this, this work is really, really important, and keep up the excellent work, and I suppose sharing that message with farmers. And it is fantastic, those farmers, I suppose, to thank those farmers who are participating in that study, who are opening up their gates to welcome visitors. It's such important. It's one thing doing the research, but it's spreading that message and getting out to the wider farming population is so important. So keep up the good work. Cathal, thanks so much for helping out with questions this morning, and special thanks to Yvonne Maher as well in the background, helping us with our the technical side. Before we finish, I just want to draw your attention to the fact that the Teagasc FBD Environmental Sustainability Awards 2025, the closing date for that is the 6th of March, so not far away. So if you or a farmer that would be eligible or would be a good candidate for this, a very generous prize fund of €30,000. So you can find out more about that on the Teagasc website, and it's open to all farmers. So please do check it out and encourage anyone you think might be eligible or interested to. It's a very simple entry process. And 6th of March, as I said, isn't far away, so do check it out. So until next week, thanks for watching, and we will be joining you, and hopefully a drier Friday next week. Okay, thanks very much.